Hi guys, welcome to another Learn Electronics Repair video. 1 or 3 subscribers asked me if I would do an inverter repair, and this is a very small one, but a subscriber brought me this in. So it says it's 200 watt DC to AC, DC 12 or 24 volt to AC 220 volts or 210 volts, but I don't see any switch on it that says how it changes the voltage, I will say. And also, to be quite honest, I'm a bit rather suspicious of this actually being a 200 watt inverter, but it says that. So he bought this locally from one of the Chinese shops who sell stuff that doesn't work mostly, and it was a few months ago and he didn't use it. He put it on one side and then he tried it the other day and it doesn't work. How bizarre. So yeah, all we can really do is open it up and have a look to see if I can figure out A, is it really a 200 watt inverter, and B, why isn't it working? Let's find a screwdriver and see if we can get inside this thing so it doesn't look too difficult. There's like just some screws on each end, yeah. So we can do this and talk about stuff. Weather's okay here. It's not the best, but it's dry and mostly warm, a bit cloudy. Don't know about where you are. And in the news, so in the news in the UK, from where I hail, and now watch from a safe distance, they have a lot of news time banging on about this cost of living crisis in the UK. Like, people can't afford to eat and heat the house at the same time and all this sort of stuff, and everybody's suffering from this cost of living crisis. And the government should do something about it, so they say. At the same time, they finished that story, having been banging on about it for 5 minutes, and they went straight to another story about chaos at the airports being half term and a lot of people go on holiday and the airports not having enough employees basically to service the people who want to fly, so they're cancelling flights and delays and stuff. And I sat there and I thought, hang on a sec. If there's a cost of living crisis in the UK, which they keep banging on about, then why is there an overload of people at the airport going on foreign holidays when apparently they can't afford to eat or heat? They have to choose one or the other. So, like, the two facts kind of don't really they're not mutually compatible, shall we say. But nobody mentioned that on the news. I thought, well, why haven't you explained why these airports are full of people who've got no money? Yeah. I do think of these things. Comments. Yeah. So now I've entertained you or otherwise with that particular story. I'm almost there and I've got most of the screws out of this. There's one screw left to go. And then we can see what's inside it. And let's see if we can actually fit. Sorry. And let's see if we can actually fix an inverter, albeit a small one, from the Chinese shop. Okay. There we go. So, well, one way or the other, one side has to go through, because this doesn't come apart, if you see what I mean. So one of these metal things looks like it needs to go sideways. Yeah, that's the way. That's the way. And there we have it. So here is our 200 watt inverter. So the first question is then, is it actually faulty now I've opened it up? Does it actually not work? Well, we'll test it how we tested the other one. We'll get a little low voltage power supply. I ought to wire a light bulb actually onto a bit of wire with a plug. That might be a good idea. Let me get that done. I bought a couple of lamp holders and a couple of bulbs from another one of the local Chinese shops a couple of 3 weeks ago. I was going to make a video actually. Somebody asked me to make a video about making these light bulb current limiters, and I will do that. So I've got these on one side, but I might do something a bit special with the current limiter. I might not actually use these bulbs. But just as another aside, some subscribers said, where do you get light bulbs from? And I said, well, you go to the local shop or the Chinese shop, and there seems to be an opinion that you can't get light bulbs. Look, well, you have loads of them. It's not like there's a shortage of them anyway, so I don't know. Come over here on holiday and get some light bulbs. So I've kind of like screwed on a little one of them, a figure of 8, i.e. C whatever the thing's called, figure of 8. I can now plug that into the light bulb, which is quite handy. And I can now stick that into the inverter and then connect the 12 volt supply to this end, and let's see what this does. I mean, this is a 70 watt bulb, so it should be well within the 200 watt alleged capabilities of this thing. Yeah, well, you'd think so. I think we're ready to go. I've switched the power supply on. I'll set it to 5 amps, that's its maximum current. I'll just switch it off one moment and attach the crocodile clip lead so we can power up our inverter. Let's see if it inverts. So this is the like lighter plug type thing. Yeah, I'm guessing, obviously. I'm guessing. It's from the Chinese shop. Yeah. But I think it's likely that the middle connection is actually the 12 volts, so we can stick that on there, and we can stick this on here, and the other one jump back off again. It's just being a little bit awkward, but let's have another go. So get on there, you bugger. You're on. Right, we're on, we're in shot, we're ready to go. So this will show us if this is going to draw any current as well. There's a little light on the thing. Let's see, you might see the light. It's kind of like, there's the LED there, yeah, down the side of there. So we're ready. Let's switch this on and see what we get. Well, we get straight away, we get the constant current light coming on. So there's a short somewhere, yeah. Or it's wanting to draw more than 5 amps, that's for sure. So let's have a look to see actually if there are any shorts that we can see on the input. Got the test meter on continuity mode. So let's have a look on our little adapter. Do we have a short? Well, strangely enough, no, we don't have a short. What about on the board? This is where it's kind of coming in. So this is marked ground, and this is marked in. You can possibly see if I just move this wire a little bit further back. In and ground. Okay, so we'll go to ground and we'll go to in. And there's no short there. There's no short there. Let's put it back on the power supply. In fact, no, let's just check. So this is from the outer side of it. We've got continuity. That should go to ground. And it does go to ground. And this is from the one with the positive end of it. And it goes to in. And it's now reading short. Well, it wasn't reading short a minute ago, you saw it. It's now reading short. There's something stupid going on here, like with a bloody, pardon my French, something stupid going on with a connector or something. No, there's nothing like wrong inside there that you can see. So that's not it. But why did it have a short and then it doesn't have a short? It's hard to imagine what's intermittent here. Let's have a look again. In. There's no short. The meter's working. Yeah. Meter's working fine. What on earth is going on here? We're getting ground. Oh. No, we don't have a ground connection. In. No, we don't have a connection. But the meter's working. Guys, this is acting like completely crazy. Positive in. In. Nothing. Nothing. You can see there's nothing there. Right, what about a bit? Nothing there. Hang on a second. Look. Positive in. Goes to ground on the board. Yeah? Why the thing back to front? Ground goes to positive in on the board. But there is no short. Either these markings on the board are wrong, or this is wired up back to front. Which one do I think they most likely to have done? Well, let's see if we can figure out. Right, we can see ground is here. Yeah. And this is a capacitor, and this is the negative end of the capacitor. And that is clearly connecting from here to here. Yeah, we can see. We can see our capacitor. And we can see the ground is here. Yes. No, it doesn't go to the capacitor at all. It goes from here to here. And the capacitor is across there. And that goes to here. I think we need to have a look at this and figure out just what we've got. Strange thing. Let's have a look. So these are two probably MOSFETs. So if they're MOSFETs, this is the gate, the one with that small track going to it. And this is the drain and this is the source. Well, they'll just read out the circuit, which is what you kind of expect. So we don't have a shorted MOSFET. Put it onto the diode mode. Do we see anything? We should see a diode junction across here in one direction. Yes. No, it's climbing up. All the way. Yeah, we see a diode junction there. That's what you'd expect from a MOSFET. If that confused you, go to the All You Need to Know About MOSFETs to Fix Stuff video. We just soon understand that. So that goes there. I'm still confused a bit. Why did I see a short and I don't see a short? There's no short there, okay? There's no short there. I don't know if I'm tempted to wire this up the other way. Let's figure out if we can see which way round this power is supposed to go. I mean, we have the two power cables coming in here. And this one that says ground goes to this component here. This is an IRF. It's IRF3205. It's a MOSFET. So we can see if that's an N or P channel MOSFET. We should be able to work out if that's supposed to be positive or negative. The other one only seems to go to this, well, this leg sticking up here, whatever it's supposed to be. And that has like another leg sticking up there, and I don't see what that should be. And also, I don't see that this lead goes to anywhere else for that matter. It just goes to this pad. I can't imagine this is anything more than a double layer PCB. So let's have a look and see if we make any more sense out of it this way. I'm on continuity. So again, we know we've got the power coming in here. And this is from the ground. This is the when I can get into a shot. That's here. That goes to there. And now again we don't seem to have a short to here, which we had before. This one goes to here, and this is the one that's marked ground on the board, but actually goes to the positive on the what coming in, which is there. Let's find a data sheet for this MOSFET and figure out which way round it's supposed to be. Here's the data sheet, or one of them. I found a few different manufacturers for this. And pin 3 is the source, and it's an N-channel MOSFET. And I have another data sheet here for the same thing. And again, pin 3 is the source, and it's an N-channel MOSFET. So you would assume that the source would connect to the ground. And in fact, it is connecting to what's marked as ground on the board. But as we know, that ain't ground on the connector. So if anybody was wondering, by the way, how long the batteries last in one of these, well, I've just found out because they've just given up, and I've reviewed it. I have to check 6-8 weeks ago. That's how long. So obviously that's the price you pay for the nice fancy display. But it takes 3 AAA batteries, so they're very cheap. And they sent me a spare set with it, which seems to be standard. Back to this. So the source is clearly connected to the terminal that says ground on here, and yet the wire clearly goes to the tip of here, which is the plus 12 volts in any car I've seen, unless you have like a vintage one with like positive earth, which you used to have. But back in them days you didn't really have these lighters, I don't think. Maybe you did. So maybe this is suitable only for vintage cars, yeah, from the 50s or 60s or something. I don't know. That is what I think is wrong with it. Looking at this now, these two legs that are sticking up actually says F1, so it's a fuse supposedly, but obviously that's not there. So why was it drawing a lot of current? Unless it was I mean, how was it drawing a lot of current? And yet it was drawing a lot of current, but the fuse is gone, literally. Yeah. Ah, okay. So let's have a look at these MOSFETs that it goes to, seeing as that's, you know, where it's been widely wrong polarity. So the first one, well, that appears to be just reading open. Let's go to diode mode. It sort of looks okay for a MOSFET, but I need to, yeah. I'm going to power it up again with the thing wired the right way round, okay. And without this fuse, I'm just going to figure out how it was even working before. I'm going to look back to the video from yesterday and see if anything was there then, yeah. It's vaporized or something. But let's wire this the right way round first, and then let's see where we get after that. No, I'm not cracking up. There was never anything there. Yeah. So, but I had an intermittent short. Let's have a look in here. I need to rewire it the right way around anyway. Oh, now the penny drops. Yeah, there's the intermittent short. So somebody's cut these wires off and put them on the wrong way round for some reason best known to themselves. But Willie, the subscriber, see it happen. You've seen him in the comments. Willie, mate, what's happened with this? Do you know? I mean, you say quite obviously you bought it from the shop and it didn't work. I'm just wondering if you have any light to shed on this, yeah? So in the meantime, comments below, mate. Yeah, let's see who is. But I mean, was the box sealed when you bought it? And that leaves like another question. If the box wasn't sealed when you bought it and the shop sold it to you, why does something that a customer's returned, which is obviously can't work, end up back on the shelf for somebody else to buy? Rest of you guys, Chinese shops, the ones we have here. I told you these old stuffers don't work. Yeah. I mean, I've bought insulation tape that isn't sticky. I've bought hammer that the head falls off. But the best one of stuff that doesn't work from the Chinese shop is soil, like potting compound for plants, yeah. So for like several years, the wife's been trying to buy, well, she's been buying potted plants and trying to grow them. And then she obviously puts them into nice big pots and they die after a few weeks. And we went to the garden centre and I bought a big bag of like potting compost. And after that, everything grew fantastic. And I said, well, where'd you get that potting stuff from? She says, well, the Chinese shop. So, not only do they sell stuff like this. Oh, and the neon tester. Yeah, I bought a neon, you know, the things you test the mains, the screwdrivers, yeah. And on the package it said, failure of the neon to light does not mean a high voltage isn't present, yeah. And then he said, do not use as a screwdriver. So it's like he's saying, well, don't rely on it to test if mains is present or not. Don't use it for that. And don't use it as a screwdriver. So I'm thinking, well, why have you sold me something that says it's a mains tester and shaped like a screwdriver, and then tell me not to use it for either purpose? I mean, what am I supposed to do with it? Yeah. Oh, I digress, guys. It's one of them days. I need some relaxation after the last video. That one was heavy going. If you've not seen it, the 2 hours 10 minutes to video, which is condensed from quite a lot more work, I have to say. It takes a long time to make videos, but although it wasn't edited as such, but there was breaks in between, yeah. And if you haven't seen that one, you should watch it because you'll learn quite a lot about testing transistors and circuits, and B, you'll realise why I was stressed out and why I need something more relaxing to do. Now I will shut up and get on with the job, yeah. Okay, so let's put these things on the right way around. That's the first thing. So we need to I might leave that bit on there, you know, and just put some heat shrink on once I've soldered it onto the right wire. I've put this back together, and while it was cooling down I had a look to see when I reviewed the Kaiwitz meter, and it was actually 5 weeks and a day ago. So to answer the question, how long do the batteries last, and considering I give this use every day, yes, I'm using this continually in the day really, there's about 5 weeks, whereas my Fluke seems to be several years. So as I say, that's just like, you know, the price you pay. Okay, so ground to ground, yeah, and the tip to the one end of the missing fuse. So let's put this back together. Let's find a fuse, solder it across there or something, and then let's see what it does. I mean, I'm just trying to think what power this would draw. We can work that out, you know. It's 200, well, it's allegedly 200 watts, yeah. So if we assume like it's 100% efficient, which it ain't going to be, then the input must be 200 watts as well, yeah. And at 12 volts, well, 20 amps is 240 watts, yeah. And that's allowing a bit for the fact it's not 100% efficient. I don't know what the efficiency of this thing is, but I would have thought that a fuse in the like 20 to 30 amps range would be about right. Just see if we get this thing back into here. It's a little bit stiff to get down there, but I'm sure I will. I bet it's the heat shrink stopping it going in properly. Yeah, that's exactly what's happening with the heat shrink on. I can't get the wires far enough in to get this to go all the way down, so I'm going to have to take this off and just kind of like redo it, yeah, and solder it to the actual directly to here. Make the lead a bit shorter. It's short enough already, but I'm going to have to do something like that. Not my best of days, is it? So of course I tried to force it to go in, and I got this to go far enough back, and then that happened, yeah. I mean, fortunately, I think Willie wants to use this with his solar panels. I'll ask him, and otherwise I'll have to find him a replacement one of these. That's my fault, so I hold my hands up. But for now then, let's see if it actually works if we replace the fuse. I've replaced the fuse. I put a 20 amp in. It seems like a reasonable value. So that should in theory give you like 240 watts, no more. We can be certain now that we have ground. Yep. Going to ground, yeah. And we have 12 volts. Going to 12 volts, that's good. I think it's probably going to be a good idea to just take these two MOSFETs out and have a quick look to see if they're okay, because they're obviously powered by the input circuit. This is like the primary of a transformer, and these two MOSFETs are in the switching circuit. Yeah, and it looks like it's a centre tap as well. And while we're at it, let's just check the coil for open circuit winding if something's blown on the transformer. So this is where the fuse comes through. So that looks okay. Reading a small resistance, you wouldn't expect much resistance. That's probably okay as well. So the transformer looks okay, and the MOSFETs are not short, but I'm just going to take them out and test them. Okay, I did these. It was a bit difficult to film it at the same time, but basically I got the hot air in one hand, and I got the desoldering tool in the other hand, and that did the job, yeah? So they're out. I'll just clean this again, and now let's have a look at these MOSFETs and see if they're actually any good. I mean, sorry guys, my camera fell over. It wasn't me, it was a camera, honest. Let's see. Yes, he's close slightly here. And if you do this before it cools down, it's much easier than letting it cool and let it warm back up again. Okay. Let's have a look at these MOSFETs and let's see. If I let me turn the desoldering tool off, because I know it probably annoys you guys on the audio, yeah? That's better, yeah? Right, let's have a look at these. Gate, drain, source according to the data sheet. Let's see. Gate, drain, source. And channel MOSFET. Well, yeah, red is the source, and that's the one that has the ground going to it now. So that's right. So that's okay. That's a good one. Let's have a look at the other one. So this appear that when somebody reversed the voltage, Willie just came in, by the way. He was with me a few minutes ago. He's a bit camera shy, but he says no, he bought it off the shelf and the pack was sealed. Although whether it's sealed with plastic or just like closed, I don't know. So there's a mystery as to why or how that wire got soldered on the wrong way round, but I doubt it came out of the factory that way. They're good then. So let's solder them in and let's see if this works. I mean, I'll have a quick look for any other semiconductors on this side of the transformer, but it's a very simple circuit, so I don't think I'll find any. But we can just check, so we can solder these in. But it appears so far that the MOSFET survived and that the fuse just blew. Okay, so that's there. So yeah, if we look down here, I mean, there's a couple of little diodes and maybe driver transistors down here. So that might be just worth a check. Well, bear in mind I'm using the bench power supply, and I'll put the current limit on it. So the current limiter should stop anything going bang, really. Let's see. Diode mode, right. So there's like obviously a diode here, and it tests okay. Tests okay. And then there's another one here, which doesn't test. Oh no, I'm on the wrong way around. go the right way, which tests okay. And then there's two little transistors or something like that in the drive circuit. Yeah, they look like maybe transistors, and that one sort of looks okay. And that one sort of looks okay. Then this obviously looks like a bridge rectifier which goes into the low voltage circuitry. I think we should just power this up and see what it does. I'm going to disconnect the load for the moment because I was thinking if that's 70 watt 220 volt, it's actually going to draw more than 60 watts on the low voltage side, and my power supply only goes to 5 amps 12 volts, which is like 60 watts. Well, there's a little LED here for power, so that'll probably give us a good indication if it's actually working. So let's connect it back to the bench power supply and let's see what it does now. I'm just going to put something underneath it. I don't like putting high voltage boards on the ESD mat, although it never seems to cause a problem if I forget, and I do that. But because I've put no load on it, I expect this not to draw very much power, so I've just set the current limit on the power supply. Just short these together, and we'll set it to about an amp. 1¼ amps, that's what it went to. Let's power it up now and let's see what it does. So we can go onto the, there we go, yeah, I've just clipped onto here, yeah. By the way, Willie says he doesn't need this because it's going to go onto his solar panels. This guy's self-sufficient, he runs his entire house from solar power. Fortunately here it's sunny every day really. So let's just switch it on and let's see what actually happens. Well, it's not drawing very much current, and the LED is lit on the back of it. You can see it lit up, the green LED. So that inverter appears to be working. Let me just find something a little bit lower power to load it with. This should do nicely. So this is a 12 volts 3 amp power supply, which I can connect to a 22 watt light bulb. There you can see it's light up. I have the power supply just plugged into the mains at the moment, so you can see that's working fine. So I'll now connect the power supply into the inverter. So we'll just take the English mains plug I happen to have on this cable and plug it into the adapter, which is here. Okay, that's it. And connect this to the inverter. So there we go. Then I can connect the power supply to the light bulb. And I can now reconnect my 12 volt power supply to the inverter. So there we go with that one. So everything's ready now. So let's now try and run the inverter and see what happens. Wow. It's drawing more than 1.6 amps, obviously. Did you see it flashing on there? That's what was going on. Let's turn up the current limit. And now it is working fine, 2.3 amps. So you probably saw that was flashing. It's because the current limit was set too low. So that inverter is actually working. It survived the stupidity of the wiring. So I really don't know what was going on there. But I'll put this back together now and pass it back to Willie, and I'm sure he'll be very happy with it. It's all back together. Let's just give it one final check. So we'll just power it up again. Yeah, and it's running fine, yeah. I'm just interested in one last thing before we end this video. Is this 200 watt rating of this inverter? Let me have a quick look at those MOSFET data sheets again. I'm interested to see how much current they can handle into the primary of the transformer at 12 volts, and that should give us a kind of a maximum wattage that it can draw from the 12 volt supply, and assuming it's near 100% efficiency, which will be less, should give us a good idea of the output. Let's have a quick look, just out of interest. Well, I have the data sheet again here. This is the MOSFET. So it says it's like 105 amps. Yeah, drain current at 100 degrees centigrade, 100 amps at 25, 105 amps, and it goes on to say that 139 watts maximum. And then you can derate that by 1 watt per degree centigrade, roughly. So I'm sure somebody can work this out better than me. But I mean, I take it as like there's two MOSFETs driving the transformer in a push-pull. So does that mean effectively each MOSFET is dissipating half the wattage each of the total wattage on the primary side of it, the 12 volt side of it? Because there's no heat sinks on these MOSFETs, but having said that, there is a fan in the back of the unit. So I don't know. I think there's a bit of wishful thinking going on here. I suspect with a decent heatsink it probably could dissipate the stated wattage. Well, I have to say the jury's out on that. It does have a cooling fan, but there's no heatsink bolted to the MOSFETs, and this is just like slid into the board. So look, I'm a circuit fixer, not a circuit designer here. Can this handle a 200 watt load? And can it do it continuously? Truth is, I actually don't know, but I suspect there's a little bit of wishful thinking going on there on the printers of the label. Yeah. Anyway, I'll try and do some more inverter repairs. I have been asked a few times in the comments, and I know there's a lot more interest these days in sustainable energy. So there's a lot of you guys interested in solar power and wind power. That's for sure. Yeah. And me too, to be honest. Even though our electricity bill is actually very cheap here. So, end of that one. One inverter working. Can go back to Willie. Hope you're happy with that, mate. You let me know, or us know, how well it works once you're using it. And for the rest of you guys, I'll see you all soon on another Learn Electronics Repair video. Ciao for now, guys.